Unit 3, Section 3.1 Objectives. Determine the empirical and molecular formula from a combustion analysis. So here's our first example, and let's take a look at what we have. 1.05 grams of a compound which contains carbon, hydrogen, and oxygen. It's going to yield 2.5 grams of carbon dioxide, 1.28 grams of water. So what we want to do first is write the potential equation. So it'll be CXHYOZ. It's combustion, so it's plus O2 yields CO2 and H2O. We are given 1.05 grams of this compound, 2.5 grams of carbon dioxide, and 1.28 grams of water. So we'll start with step 1, where we're going to take 2.5 grams of CO2, put it over 1, and what we're going to do is bring down the grams of CO2. We're going to use the molar mass, which is 44.01, and then we're going to go to the grams of carbon that's in this compound, and this is known as the fraction by mass of carbon. So first I'll write this, and this is known as the fraction by mass of carbon. And so now that I've done this, we can calculate 2.5 divided by 44.01 times 12.01 is going to get us 0.682 grams of carbon. We're now going to take the grams of carbon that were produced divided by the grams of carbon, or the grams of my entire initial compound, which is 1.05 grams, times 100 to get the percentage that would be carbon, in which we would get 64.97%. So now I'm going to do the same process, but for hydrogen. So we take 1.28 grams of the water, bring down grams of water, and that's 18.02. And then within the compound of water there are 2 hydrogens, which is going to equal a total mass of 2.02 grams. That's going to be of hydrogen in water. So that's our fraction by mass of hydrogen. So 1.28 times 2.02 divided by 18.02 is going to give us 0.143 grams of hydrogen. We're going to figure out the percentage now of hydrogen in the original compound, which again is 1.05 grams, times 100, and that's going to give me 13.67% of hydrogen. Now we want to determine how much oxygen there is, and we know that 100% of the compound is the carbons, the hydrogens, and the oxygens. So we can actually take 100% minus the 64.97% of carbon minus the 13.67% of hydrogen, and when we subtract those, we get 21.36%, which is oxygen. So now we're going to actually determine, using the 3 percentages, the empirical formula. I'm going to go ahead and assume each of these percents represents grams. And so I'm going to take my 64.97% of carbon, and that's going to be divided by the molar mass of carbon. Hydrogen is divided by the molar mass of hydrogen, and oxygen is divided by the molar mass of oxygen. This gives me 5.410 moles of carbon, 13.53 moles of hydrogen, and 1.335 moles of oxygen. Now we're going to do what's called divide by the small. of these three, 1.335 is the smallest value. So we're going to divide each of these by 1.335. And when we do this, we're going to get a whole number where this is going to equal 4 carbons. This is going to equal 10 hydrogens. And of course, 1.335 divided by itself is going to equal 1 oxygen. So our formula is C4H10O. And that's going to be our empirical formula. We'd have to be given the molecular weight of this compound in order to determine the molecular formula. So for now, we'll just stop at the empirical formula. .86 grams of the compound, which contains carbon, hydrogen, and fluorine. It yields 3.72 grams of carbon dioxide, 0.39 grams of water. What's the empirical formula? So first I'll write what the reaction may look like. CxHyFZ plus O2 yields CO2 plus H2O. We're given 1.86 grams of our original compound, 3.72 grams of carbon dioxide, and 0.39 grams of water. So I'll start with my carbon dioxide, 3.72 grams of CO2 all over 1. And now we'll bring down grams of CO2 and we'll do the fraction by mass. 44.01 is the molar mass of CO2, and we have 12.01 grams of carbon within the compound. This is going to give me 1.01 grams of carbon. Take my water, 0.39 grams of water. We'll do a fraction by mass with water. So there are 18.02 grams of water and 2.02 grams of hydrogen in water. Do that math. It's going to equal 0.0437 grams of hydrogen. So now we're going to determine the percentage in this compound by dividing by 1.86. So we'll actually divide both of these by 1.86. 1.86. And then times 100 will make it into a percentage. So we have 54.58% of carbon, and we have 2.35% of hydrogen. To determine our number of fluorine, we take 100% minus the 54.58% of carbon minus the 2.35% of hydrogen, and that's going to equal 43.07%. So now I'm going to go ahead and divide each of these by their respective molar masses. Remember, we're going to go ahead and just consider the percent sign the same thing as a gram. So here, molar mass of carbon is 12.01, molar mass of hydrogen is 1.01, and the molar mass of fluorine is 19.00. That gives me 4.54 moles of carbon. This gives me 2.327 moles of hydrogen, and this gives me 2.267 moles of fluorine. Now we're going to divide each one by the smallest, and the smallest is going to be 2.267. So we'll divide each by 2.267. This is going to give me 2 carbons. This is going to give me 1 hydrogen, And this, of course, is going to give me 1 fluorine. So our formula is going to be C2H F, and that's the empirical formula. Again, we'd have to have the molar mass or the molecular weight in order to find out the molecular formula.